give context in terms of the climate action plan and the climate change strategy that the municipality is using. So Durban's climate action plan, which was launched in 2020 in partnership with the C40. I'm sure we know this has been talked about before. C40, which are the cities leaders group of about 100 or more major cities worldwide that align Paris Agreement. It addresses the 9 critical areas, which is the energy, it's the transport, it's waste, biodiversity, food, health, sea level rise, and vulnerable communities. So all our projects basically wants to respond to all of these critical areas. So we also know that the Climate Action Plan has the emissions targets, which we sort of feel that they're a bit ambitious when you look at the state that we are in at the moment, where they say it's 40% reduction by 2030 and 80% by 2050. And then we are aiming to drop 5.9 metric tons of carbon per person from 2015 to 2050. So the Paris Agreement supports the city in creating the climate action plans, which is aligned to the limits to limiting the global warming to 1.5%. And this is a crucial state because we want to avoid the most severe impact of climate change, which could be possible if we are unable to reduce the global warming. So these are the key sectorial areas. I think we've just mentioned it's energy, it's transport, food and waste, just as a summary, and resilience, which talks mostly about the communities. So our projects are centered around energy, food and waste, and then resilience. So our first project, I just picked just a few projects because we can't share everything here, but I think this projects already, I think Prof. Van Rensburg spoke about briefly when she was talking about carbon and sequestration. So this is one of the projects that we are busy with. This project, one of the ladies is registered for a doctoral study at Wits. So we are not going to share much on it, but basically it's about sequestration of greenhouse gases into soil. I think Prof already gave us a little bit of background of why that is important. You know, obviously organic carbon improves the soil binding of the particles, and also it makes the soil more fertile to give us higher yields in terms of agriculture and food security. And the second project that I want to speak about, I think again Jane from PAMSA sort of spoke about something similar, production of bioethanol in our case from sugarcane bagasse. I think we find comforts because one of our colleagues just spoke about the fact that the sugar industry is saying they are struggling, you know, and they are looking at other streams, you know, getting products, not really sugar, but something else. So when you look at projects like this, then you think, okay, maybe we are really thinking forward on what could be done in the future. So here, again, we want to convert. So again, we are speaking to the circular economy principles, and we want to use the biomass and convert it into bioethanol. There's so many advantages of that. Obviously, we want to replace fossil fuels. We want to reduce the reliance on non-renewable energy sources and so on. So again, I'm not going to waste time because most of the speakers gave a background to the circular economy principles and how it is important in clean fuels. And then our third project is on recovery of the metals from e-waste through hydrometallurgical process and green chemistry. Like I said, I'm from the chemical engineering field, so this fits well with us once again. So here, similarly, we want to contribute to a circular economy where we want to reuse, right, and try and benefit from this waste, which is the electronic waste. I'm sure we are moving from one type of waste, which is paper. We are saying we have reduced the use of paper because everything now is electronic. I don't see anyone with an agenda that is printed at the moment. Everyone has it on their cell phones or on their devices. However, these devices, at some point, we need to throw them away. You know, they get damaged or maybe they don't work anymore. So what do? Do we throw them in the bin? Probably not. But because at the moment we don't have a clear demarcation of waste, you will find that a cell phone is put with the domestic waste and so on. But actually we can be able to recover some of the metals that are here on these devices. Right, so this project is looking at that. Obviously, you want to use leaching process, so I'm not going to give all the technical information. But again, bottom line is that we are looking at contributing to the circular economy, just like the previous speakers. Just as the concluding remarks and the way forward for us, we didn't put many of our projects which are community-based because we just wanted to fit with the theme here. But why women? So because we are a group that is called Women in Climate Change. So obviously we are saying women often possess valuable indigenous knowledge related to agriculture, water management, and natural resources, which can be leveraged for climate resilient strategies. I think Ms. Sharma also spoke about the fact that when she works with the communities, she finds that there's a wealth of knowledge from communities, even though they cannot package it as scientific knowledge. But if you speak to them and you talk to the women in the rural, and then you speak about maybe why are you no longer producing maize here, and then they will tell you, oh no, because it's no longer raining from this year. We have seen that it doesn't rain, or this is happening. So they've noticed all these patterns, right? These climate patterns over time, even though they don't have the terminology for it, like the scientific one that we write with in our published work and all of that, but there is a wealth of information that can tell you exactly when this started and how it has affected them. So we are saying, let's leverage on that. Let's capitalize on on that information. So the women that are in agriculture can also assist. And also the fact that women has an ability to mobilize, we think, mobilize the communities, they can mobilize the youth as well, which we feel is very important when it comes to climate action. Actually, if you want to, put it back into the community and you want people to implement whatever strategies, we can all speak in these rooms, but at the end of the day, when the implementation time comes, the the communities need to be involved. So why not involve them at the beginning whilst we are in the planning stages, whilst we are still talking about this because of the information that they already have. And then in terms of the stakeholder engagement, yes, we've got many stakeholders. My colleague Prof has just spoken about eThekwini, which is our biggest stakeholders. We have MOUs, we have working with universities from the US. We have SANEDI, which is the National Energy Development Institution, GIZ. I'm sure my colleagues yesterday, they spoke about the German Development Agency, which donated equipment for greenhouse gases monitoring at MUT. We are going to be using that units to demonstrate to community members that wants to come for short courses on climate change and greenhouse gases monitoring. We also have other stakeholders like CSIR, other academic institutions, and of course the government institutions as well. So in summary, all our projects are advocating for climate smart agriculture and food systems, renewable energy, and waste reduction. Thank you very much.
Well, thank you very much to Prof. Mkhize and Dr. Makatsini. I know that it's time for input or questions, but I will suggest that we try to push our program. I'm worried about time. However, we've started in the morning. We never had a break, just 5 minutes smoking break, so that people can grab tea and sit down, and then we continue. We'll take a discussion after the 3 following presentations. Just to stretch, for stretching. I can feel a sense of tiredness now. So it's important that we just Teams to climate change. For 20 minutes.
Honorable Premier, MECs, HODs, and colleagues, good day. Premier, I would be failing not to extend sincere appreciation for the staff that is in your office that is coordinating this function or workshop. I must say up front, they've been sincere, they've been able to take calls at awkward hours of the night, and I want to say thank you, colleagues, for making it easy for us to be able to get our work done. Thank you so much. Perhaps that's part of indigenous knowledge. That uphathwa kahle umuntu uma esebenza. As an introduction, I would like to outline my presentation. I would go to definitions, both indigenous knowledge system as well as climate or knowledge systems, as well as also look at the key institutions for policy implementation, and look at the existing policies supporting the indigenous knowledge systems as well as climate integration, look at the policy implications, and the most spoke about topic, funding mechanisms. I might take longer, the Premier. If you block me, it means there will be less information, Premier. And then I'll go to conclusion, and which I've summed up as a call to action with what, who, when, and by whom. There's a common thread that has been resonating in this room. People on the ground know the information. People on the ground are local bearers of information, which is diverse, and people are making best use of that knowledge in terms of as early warning systems. And you find that the key components in terms of knowledge management is knowledge creation, knowledge storage and retrieval, knowledge sharing, and knowledge application. And one of the things that, or one of the facts that were coming through is that this knowledge is oral, experiential, and context-specific nature. In other words, it applies, as my colleague on disasters said, what happens in Durban South Basin, only Durban South Basin applies in Durban South Basin, nowhere else, because of the thing. And then the things that they do will be applicable there, and they will differ from other areas that are part of Durban. Premier, because it is oral, there is a risk of cultural loss and knowledge erosion because it is not documented. But I heard that in Durban South Basin, people now have documented, they know who's where. They even went to a greater extent of getting the DNA, so should things go wrong or go south, they are able to track who's who and from which family. Premier and members, the knowledge that people have has been abused and stolen. Intellectual property and ethical use gives us concerns because people have benefited extremely at the expense of the people that are knowledge owners. Power imbalances in decision-making and data control also falls part of this. As I said, indigenous knowledge system is traditional, based knowledge passed through generations, holistic understanding, integrating ecological, cultural, and spiritual elements. And it is definitely crucial for sustainable environmental stewardship. As you heard Nkosi Zarawantul yesterday expressing that for them to protect their environment, they plant trees or indigenous trees in the right places, and they do things that are making the life easier for people on the ground. As I said, indigenous knowledge system involves knowledge and practices, belief systems, transmission, holistic, and it's community-based. And some other people have already said that it affects, this knowledge resonates well with agriculture and health and medicine, also environmental management. And there's a social organization that speaks about the governance, and it has been coming through out in these presentations. Why indigenous knowledge system? It offers valuable insights and practices that can enhance resilience to climate impacts. And it also it indicates that indigenous communities have a profound understanding of their local system, ecosystems. This has been a common thread in almost all the presentations. And it, I liked when, I think it was a lady from somewhere in Devon, she said, when the cat starts behaving awkwardly, then they know that there's something wrong. Perhaps it might be that the cat is only seeing a snake, but it allows them to observe and respond to environmental changes effectively. Of course, indigenous, the key contributions is detailed observation of climate and biodiversity changes. And example of this, traditional fire management, seasonal shifts in plant and animals, indigenous water conservation methods. This image depicts traditional fire management practice used in South Africa to reduce wildfire risk. There's risk assessment, stakeholder organization, fire management, planning and implementation. There's detections and suppression, rehabilitation, and you go back to look at the risk posed by the environment where you are, where fire might take place. This is the EPWP adopting the knowledge that was gained through that process that was used by our forefathers, that is in fire management. This one is indigenous water harvesting methods, where there's rooftop rainwater, there's flood and overland flow harvesting, and groundwater harvesting. But there are challenges. You find that there's limited integration of indigenous knowledge systems into formal climate policies. Other people still undermine the information that people have. Who the hell are you to tell us when we've got our doctorates? And I think the person, a colleague from who spoke about Devon South Basin, they'll tell that people have got the best information, regardless that we are a doctor or we are a professor. People on the ground have the best knowledge because they live there. You come and do your research, they live there. They experience this thing day in and day out. Community-based adaptation practices demonstrate greater ecological sustainability and local appropriateness compared to externally imposed scientific interventions. And that has come through as well. And there is emphasis on hybrid approaches. In other words, instead of having a scientific only approach, bring this together. Let them come together, fuse them together, rather than treating indigenous knowledge system as a competing paradigm. Premier, the most important thing that one has to note is that there are key institutions for policy implementation. DSI, Department of Science and Innovation, it oversees indigenous knowledge systems, policy, and research. So whatever we do, if it's got to do with policy, we need to partner with them. Department of Forestry, Fisheries, and Environment, DFFE, it integrates indigenous knowledge system into climate plans. Whatever the province has developed, they need to integrate it with the national department so that there is synergy between what national department is doing and what we have on the ground. There's again a South African National Biodiversity Institute, and somebody was just saying there's a lot of money from SANBI that is coming through. I think it was one professor, and they document indigenous ecological knowledge. And the last one is National Indigenous Knowledge Office, NICO, which implements indigenous knowledge systems protection laws. So from here, we have got critical stakeholders that could sustain and help us drive the process that the Premier wants us to achieve in terms of what happens in KZN. Existing policies, we've looked at the departments. Now we're looking at the policies that support indigenous knowledge system and climate integration. First, there's Protection of Indigenous Knowledge Systems Act of 2019. Its relevance is that it is a legal framework for indigenous knowledge systems protection. However, there needs to be a stronger enforcement and digital rights management. Then another policy is National Climate Change Adaptation Strategy. It recognizes indigenous knowledge system in resilience planning. However, it needs dedicated IKS implementation plans. There is white paper on science, technology and innovation, which was developed in 2019. It promotes indigenous knowledge system in research. However, also it requires more indigenous-led funding. The last one, Premier, is the National Biodiversity Economy Strategy of 2023, which links indigenous knowledge to conservation. One person, or the author of what I read says it should include benefit sharing mechanism. It must not be one person benefits out of this exercise. What are the policy implications and support for indigenous knowledge in knowledge management and climate change data? There is illegal recognition and protection of indigenous knowledge system. I said earlier on, indigenous knowledge is often exploited without consent or benefit sharing. What should we do? Strengthen the protection and promotion and development management of Indigenous Knowledge Act to ensure that data sovereignty as well as we prevent biopiracy. Let people not benefit and get rich at the expense of people who have got the information. Secondly, ethical data governance and ownership. Indigenous communities often lack control over how their knowledge is collected and used. We've got to adopt the principles of FAIR as well as CARE. FAIR represents findable, accessible, interoperable, and reusable technical aspects of data management. CARE represents collective benefit authority to control responsibility and ethics. 3, Institutional support for indigenous knowledge system, climate and integration. People have been speaking about fragmentation, which appears to start from the ground, right up to the national department. People stress that there's fragmentation efforts between government, academia, and indigenous group. And what Premier has put together is a team that will answer that question: what, where, who, and how. And in that way, we'll be streamlining our efforts in such a way that we are able to do one thing at the same time and, pull our resources together. So in doing so, we'll need to integrate indigenous knowledge system into the National Climate Change Adaptation Strategy as well as National Development Plan. The last Premier here is mainstreaming indigenous knowledge system in climate change reporting and decision making. I said earlier on, science is always preferred to indigenous knowledge system. Therefore, we should avoid sidelining indigenous knowledge system in official climate policies. What needs to be done, we require indigenous representation in climate advisory bodies, and we should include indigenous knowledge system indicators in national determined contributions and national biodiversity strategy. There is funding. There is lots of funding. And you could see that colleagues know funding from various corners. But if we can each research on these, we'll be able to find which fits where and which is available. If there is so much funding, how come are we not able to get it? In fact, one lady yesterday who was speaking with, who was sharing a platform with one of the speakers, said she's dealing with carbon, I think carbon issues, but she doesn't have funding. Now, the question is, there's so much funding here. How is it that we are unable to? That's a question that we need to ask ourselves. Why are we unable to tap into this? And what are the steps that we need to have in order or adopt in order to get this funding? Okay, now I'm going back. Okay, conclusion, a call to action. Premier, as you correctly said, there are certain things that need to happen. As government, we need to mainstream indigenous knowledge system into climate policies and funding mechanisms. Secondly, academia and research institutions, some of them are here, some of them I have not attended. We need to find a unit or within the Office of the Premier to coordinate this research with these institutions so that we prioritize transdisciplinary studies that honor indigenous theory of knowledge. Civil society and NGOs should be able to amplify indigenous voices in climate advocacy. We had MUT drilling on advocacy. Private sector should invest in indigenous base, in IKS-based sustainability innovations. Traditional leaders, Abonda Bezita, and communities to safeguard and share knowledge in ways that ensure sovereignty and benefit sharing. This is one of my last but one slides. Indigenous climate resilience strategies in water system. For sustainable water management, activities that people have been doing, they've been harvesting rainwater. They established conserving ponds and wells, and they've been restoring natural springs. And the benefit out of that is that restoring natural springs to improve water, it improves water availability during difficult times. I think one lady was speaking two speakers yesterday, I think, they referred to South Africa and in KwaZulu-Natal as a particularly dry part of the country. So we need to restore natural springs to improve water availability so that we need during times of drought and erratic rainfall. Nature-based solutions. You know, we need to construct small-scale infrastructure like infiltration trends where water is led, and as it moves slowly, you find that it is able to infiltrate the soil. This helps to reduce surface runoff. It enhances groundwater recharge and protects water sources from it tells me that my 20 minutes is over. And protect water sources from erosion and pollution. Physical protection measures. You know, we would find that in areas where people value springs, they build around that spring. They put circle of stones or rocks around that source so that this area would protect water from pollutants and animals. This is what people do. Ningacabangi okunye lithi ibandla elithile caca. The last slide, Premier, it's on, first it was water, now it's waste strategies. It is so interesting, you know, having worked with, having been blessed to work in environmental affairs. You go to Durban after a flood, beach, you'll see how many shoes are collected by these river canals and deposited on the beach. Secondly, how many plastics are deposited on the beach. So people had indigenous ways of handling waste so that it does not impact negatively on the rare resources that we have. Intentional consumption and sharing. In other words, when people have got food, it's a timer. Intentional consumption and sharing. You see, when you have got an abundance of food, instead of storing it and hoarding it, share it with other people. You find that there is less waste generated because you are sharing. They will share with you. That the climate benefit is that there is resource conservation and low emissions. Regenerative agriculture. Somebody spoke about that. There are systems. You grow something, and in between what you have grown, you grow other type of plants. That enables you to retain soil moisture, fertility is encouraged, and biodiversity is enhanced. Those are closed type resource cycles. Collective governance, I spoke about collective governance. In other words, there are people who are there to ensure that what we have is taken well. And it's adaptive management, it's social resilience. In other words, there are people who will be there even if things go well. So sustainable practices are ensured when we have got collective governance. There's the reuse, repair, and repurpose. This reduces material, new material demand. And somebody was saying there is a lot that you can do with whatever you have right now. So it could assist into a circular economy. It could assist in fact, it was Professor Timothy. It could assist in ensuring that local climate is enhanced. Then that repairs damage. composting, systematic decomposition. Let us preach that food must not go to waste. It could either be recycled and Babu Mswema was saying that there are industries that can be created through, food waste. Let us ensure that we subscribe to that so that our soil health and carbon storage is enhanced and nutrients are recycled by doing that. Pollution prevention protocols. If we follow protocols that are established, we'll end up with clean land, we'll have clean land and water, and our river systems, our ecosystems would function optimally. Last but not least, modern plus traditional integration. If you mix the two, you are able to get a strong adaptation, innovation, and that's all that I have to say, Mr. Premier.
Thank you, Dr. Ngoma. The next presenter is Dr. Mbata from CSIR, who will be presenting from in a virtual platform, I'm told. Is Dr. Mbata present here? Presenting on a virtual platform. Okay.
Yes, I can share. Can I confirm if you can see my screen?
Yes, I can confirm. Yes, I can confirm for your 15 minutes time. Is it?
Thank you, my prima.
Oh, it's 25 minutes. 25 minutes.
I'll not take a long time, my prima. I'll spend this time maybe just to greet everyone. Bingelele kakhulu, my honorable premier, bingelele nama MSCs, bingelele traditional leaders, nama council members, and everyone all the workshop here climate change. So maybe just to start with, yes, I'm from KwaZulu-Natal. I also was part of the climate change, KwaZulu-Natal Climate Change and Sustainable Development Council. Our tenure ended last year, but of course our first few years were disturbed by COVID, but maybe we are not that active in the last 2 years. So this is really a good and a big opportunity for me just to talk about the scientific evidence that is with this climate change. So I'll touch a bit on data, information systems and tools, but well, maybe I'll just merge that, just maybe show you the scientific evidence that we talk about, and maybe talk about the tools that are required. So it means the talks that were here are very, very important, but maybe I'll divert a bit and talk the actual scientific evidence of climate change. So I'm with the Climate and Aquatic Modeling Group at CSIR, formerly at the University of Zululand, until last year, September. So I'm here now. So maybe if you want to see more about what we talk about, you will notice, you will go to maybe LinkedIn, just check my page. I will normally post things about climate extremes in KwaZulu-Natal, which I do in our office here at CSIR. For instance, this is an example of heat wave index. For instance, you can see your areas of Kanyabude, Zululand district, and some part of King Cetshwayo with high frequency of heat waves. For instance, if you stay in Mpangeni, you know what I'm talking about. Well, traveling from Guatemala to Mpangeni during those days, you know very well what I'm talking about. So even if you go to maximum length of those heat waves, you can see such maps. So we sort of do those displays and sort of define the significance, the scientific significance of these trends of heat waves. So go to my LinkedIn, and I'm Zulu, so you can also ask in Zulu. I will explain some of the things to you. But maybe if you want to track us, we are at the Holistic Climate Change Impact Area, which is under Smart Places. I'm doing this because I know you want to talk to me. but just to track me, go to smart places and go to the HC impact area, you'll find us. You'll find two groups there. We are, bringing solutions. There is climate services and climate and air quality modeling group. Climate services will bring you solutions regarding your sector climate change adaptation. They also do climate mitigation. They also do your climate finance and climate resource economics. But myself, I'm the research group leader of the climate and air quality modeling group. So we are dealing with climate evidence, climate analytics. So we do climate change and climate variability modeling and air quality and greenhouse gas emission modeling. So, for instance, KwaZulu-Natal would want to, have its high quality greenhouse gas inventory or greenhouse gas emission data, which we can easily do for them. I think the last time when we were with the council, I was with the council, this is one type of the work we wanted to do so that we can be able to and see very well the climate of the province. So maybe I've spoken about most of these things, but I want to talk about the consultation and capacity building. We are aggressively taking that direction now to make sure that we train our people on how to display and also how to produce the scientific evidence. So we will teach you the programming that is required for you to deal with climate data. Invited by Ghana tomorrow. That's why I can't be there physically, because of course it would be nice to be there at home. But we will be going to Ghana tomorrow. They are going to be doing climate data analytics with us. So we'll spend a week there. So this is one type of thing that we want to do for Department of Water and Sanitation and other departments that are relevant to environmental sciences in KwaZulu-Natal as well, if it is possible. Give you these tools so that you can have your own high quality reports and systems that can help you easily sort of forecast and project these climate changes. Yeah. Okay, so the climate modeling is very important. This is our main core of my group. We are aggressively dealing with the climate services and the decision support tools, such that, for instance, there are things that are happening in KwaZulu-Natal, and we want to make sure you are very well vested with the statistics of that. So we do climatology. For instance, we'll give you projected trends and your extremes, your attributions. We also do machine learning, deep learning, downscaling of some of our models as well, so that we capture smaller errors up to as small as some of the small catchment areas and so on and so on. So we're doing a lot of that, climate change detection and attribution. We're also doing a lot of climate variability, tailored for climate services. So we'll give you also your seasonal forecast. We'll give you also your weather forecast. Of course, we are not legally mandated to produce some of those, for instance, the forecasting, weather forecast sources is legally authorized, but we have all that in our disposal, of course. So I'll show you some of the results. We are running models. The main model that we are running, we have several models, but I'm just picking this one just to show you that we drive our CCAM model using CMAP5 initially, and we moved to CMAP 6, and now we'll be doing CMAP 7, very high quality projection of climate, and also seasonal forecasting and weather forecasting of the earth systems. So we downscale that using machine learning so that you can apply this to your hydrology, for instance, catchment level, also look at climate extremes and so on, flooding and many other things that are going on. And on top of that, we have make sure that we move towards the hydrological modeling aggressively because of the issues of water. So we do what is called WAF Hydro and other models like JOLTS, just to make sure that we have these tools that we can, help stimulate the system in terms of surface water hydrology. On your bottom left there, I quickly did a vulnerability map. Flood vulnerability map for eThekwini region, just specifically for this talk, just to show you areas which are vulnerable to flood. We can do the same thing with your heat wave, for instance. I have a student in the University of Zululand who is doing heat wave mapping for the whole KwaZulu-Natal province, just for you to be aware where you are and areas which are vulnerable to heat waves. Or you can also do the same for flooding and many others of these climate extremes. So those tools are there. That data is, we are able to produce that data, and all those things are available. We're also doing a lot of remote sensing applied to agriculture. We have done a lot of projects where we look at, for instance, the forestry in KwaZulu-Natal, its response to climate dynamics. So those type of things, even sugarcane, you just come up with your own issue and we try to solve it as much as we can. Of course, this left part is about the hydrological modeling that we do. I'm sorry I'm a bit fast because of time, but just for your help, you can also get a lot of this data and some of these tools that can help you access the data that can help you in terms of this. There is what you call Earth Engine data catalog. You can check there's a whole lot of data that can assist you bring scientific evidence that can solve your problems wherever you are, especially in KwaZulu-Natal, my province, where we have been seeing a lot of extreme events. But you can also do, you can also look at your NASA systems. They're giving you a lot of high resolution data that can help you. Even Giovanni can give you data that is tailored to, for instance, your atmospheric chemistry, dynamics, hydrology, and so on. You can do your own climatological analysis, so climate variability, and so on. They also will give you the climate projection data so that you know what is going on. For instance, if you want to know some of the tools, I suggest Windy. I have it in my phone. It's a very simple system. For instance, I'm going to Ghana. I already know how will be the temperature and rainfall for the few days there. And here, just before this talk,
Well,
sorry. Hello?
oh yes, you are back now.
Oh, I'm back. Oh, sorry about that. So I'm showing an example of a windy image, and you can see in the east of the Eastern Cape, East London province, you'll notice that there's something going on there. It's a low pressure of some sort. And imagine if you can look at these things. Normally, low pressure will come from the Indian Ocean and in time. So if you are able to look at them and see how they're moving, then you are able to do a forecast for yourself and help yourself. There's this nice tool which is called Windy. You can also get an app that you can use in your phone. You can check temperature, rainfall for any region. For instance, I've checked Ghana. We are going to Ghana, so I know exactly what is going on there. But anyway, we're doing a lot of things: climate data analytics, climate projection. You will notice for the whole Africa continent, we can give you, a drought profile and the trends of drought. If you go down there in that time series, I quickly did a downscaling of CMAP6 just for this talk, just to show you that you can project the next, I projected the next 5 years of rainfall over Durban, the city. So something like that. So this is important for decision making. If you know that, then you can easily know what is coming towards you. Of course, we are characterizing cutoff flows in my group just to make sure that we understand their frequency, we understand their statistics, so that we have better systems in terms of modeling. Because you want to be accurate in terms of when do they come, so that we have better decision making in KwaZulu-Natal. So droughts and everything, we do that, and of course we teaching a lot of our people how to produce this type of scientific evidence as well. For instance, a good example, I remember I said we are not mandated to sort of give public give this, but you can get this information for us. Of course, we're doing focus. For instance, cut-off flow last year in KwaZulu-Natal, we focused it way before time. We look at it, of course, maybe in our office. And if you remember the snow that you have, if you look at your right, your 4 graphs on your right-hand side, you will see that brownish area. Those are snow locations, which we were able to forecast a few days before they happened for KwaZulu-Natal, using our own models in CSIR, something like that. So we do have these systems that are sitting specifically for different provinces and different areas, but we'll normally look at KwaZulu-Natal because we know there are a lot of issues in terms of climate extremes. We have looked at flooding risk factors for KwaZulu-Natal, but we compared KwaZulu-Natal with the Western Cape province. We'd use satellite data to sort of drive our models so that we can create systems like, when we want to, when we have power lines in KwaZulu-Natal, you sort of want to see which ones are vulnerable to, for instance, flooding, for instance, heat or fire issues and stuff like that. We'll map that for you. So this project was about that. This is an example from an ESCOM project. So we'll locate exactly where those areas could be, where the areas where the power lines would be vulnerable, or even the workers will work in these stations. Like I said, we also do, greenhouse gas inventory. I'm showing you an example here where we recently did PM 2.5 emissions for Gauteng.